with the NCERT Exemplar of Class 9. We will cover the first chapter, number system, and this is exercise 1.1. So without any further delay, let's move to question number 1. The question number 1 says, write the correct answer in each of the following. The first part is, every rational number is, whether a natural number, an integer, a real number or a whole number. See, it's easy to memorize the concepts. Instead, let's look for the basic idea of it, and then we will be able to solve all these kind of assertions and reasons, right? First is, we know that the smallest set that we have in number system is of natural numbers. Then, the bigger one is whole number, which includes 0. And then it is overlapped by the integers, sometimes presented by I or sometimes presented by Z as well. Now, this whole system is again overlapped by the rational numbers, which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. Along with this, there are some numbers which are called irrational numbers. Basically, you can say the numbers which are not rational and cannot be represented in the form of P by Q are irrational numbers. Now, if I combine all these systems together, they are contained in a bigger system which is called the system of real numbers, right? The real numbers represented by R. Okay? When question says every rational number is, so every natural number is a whole number, every whole number is an integer, every integer is an rational number, and then every rational number is a real number. Taking this kind of hierarchy, we will click on option number C, that is a real number. Moving further, our question is between two rational numbers. Option A, there is no rational number, there is exactly one rational number, there are infinitely many rational numbers, there are only rational numbers and no irrational numbers. Now, let's check for this one. Do you know two rational numbers? Just assume any two. Let's say I'm taking 1/4 and half. Both of them are the rational numbers, right? 1/4 is smaller and 1/2 is a bigger one. So I have written one on the left and one on the right, respectively. Now, for example, I want to find out, let's say, 4 numbers between these. So I can simply multiply by 3 here and by 6 here. It is nothing but 3 by 12 and this is nothing but 6 by 12. How will I mark? It will be 4 by 12, 5 by 12 and then it will be 6 by 12. Am I right? Yes. So there is no rational number is an incorrect option. There is exactly one rational number, again it's an incorrect option. There are infinitely many rational numbers, yes it is possible. And there are only rational numbers and no irrational numbers. Let's see if there are no irrational numbers. For example, if I say 1/4 is nothing but 0.25, right? And 1/2 is nothing but 0.5. So obviously there exist so many numbers like 0.3, 0, 1, 2, 3, 4, the numbers which are non-terminating, non-repeating, right? The irrational. So obviously there are irrational numbers. That is why option D won't be the correct one and we will opt for option number C as our correct answer. There are infinitely many rational numbers. Option D could have also been correct, but they have mentioned a condition that there are no rational numbers. That is wrong. Moving to the next question. The question is, decimal representation of a rational number cannot be. Okay. So we need to be very careful when we are selecting the decimal expression of a rational number. How do we define it? See, rational numbers, when converted into decimal forms, they come into 2 forms. The first form is they terminate, means they completely divide. Right? The dividend is completely divided by the divisor without leaving any remainder. Or they might not terminate, means they'll be keep coming. The remainder will be always there and we'll be doing the division again and again. Then there is a possibility that this non-termination is repeated. But in case the number is neither terminating and non-repeating, neither terminating nor repeating, then it will not be under the category of rational number. Instead, it will become an irrational number. So, decimal representation of a rational number can never be non-terminating, non-repeating, because it is the decimal expression of an irrational number. Moving further, the product of any two irrational numbers is two irrational numbers. Let's see what are the two irrational numbers that we can consider. The first irrational number, let's say it is 3 by 2, just for an example. And another number is root 5 by 2. Right? When you multiply, you will be getting root 15 by 2. So yes, it is an irrational number, it is an irrational number, and again the result is a rational number. So yes, the product of two irrational numbers could be an irrational number. What else could be there? For example, we take a number like 1 by root 2. Okay? And another irrational number, that is root 2. But when you multiply them, you actually get 1. So this is an irrational number, this one is also an irrational number, but the result is a rational number. That is why the product of any two irrational numbers can be irrational or can be rational sometimes. Agree? Great. So option D will be the correct answer. Question number 5. The decimal expansion of the number root 2 is. See very carefully. If you observe, it is an irrational number. So obviously it can never be a finite decimal. So option A would be the wrong answer. Then they are saying non-terminating recurring. I have told you in the previous question, non-terminating recurring or repeating is again a type of rational number. So option C will also be incorrect. Now there are two options, 1.41421 and non-terminating non-recurring. See, generally we see this expression and we mark the value of root 2 as 1.414. But in reality, root 2 is an irrational number, and irrational numbers are non-terminating, non-recurring. So option D will be the correct answer because this is the incomplete value of root 2. Okay? Moving to the next question. This is, which of the following is irrational? Now we will be solving each of the options and then we will get to the conclusion that which one is irrational. This is root 4 by 9. Can we write it as 2 by 2 divided by 3 by 3? Obviously, because we have to factorize them in the prime factors. And when they will be pair up, it will be 2 by 3. So, it's an irrational or rational? Rational number. Now, the B part is 12 by 3 whole root. Now, it would be 3 by 2 by 2 and then 3 in the denominator. You can cancel 3 and there will be a pair. The answer would be 2, which is again an irrational number. Root 7 cannot be further divided, so it will be an irrational number. Root 81 can be mentioned as the factor of 9 by 9, so it will be 9, that is a rational number. So which among the following is an irrational number? Absolutely. Option C, root 7 will be the correct answer. Moving to the next. Which of the following is irrational? Now you see 0.14, right? It is terminated, but irrational numbers never terminate, right? So this is wrong. Again, 0.1416. Can you see this sign? This sign actually represents the recurrence or the repetition. So again, it is repeating, not terminating, but repeating. So that is also a rational number. Here also we can see this sign of repetition, so it is again a rational number. We are left with option D, which is neither terminating because there are ellipses and it is not repeating as well. right? So 7th question, option D will be the correct answer. Moving to the next, question number 8. Question is, a rational number between root 2 and root 3. First thing, we know that root 2 and root 3 are irrational numbers. Agree? Root 2 and root 3 are irrational numbers. Right? So what we will do, we will simply find out the values. 1.414 and then root 3 would be like 1.732 and so on. If you want to find out a rational number between them, you can simply figure out a number between 1.4 and 1.7. That is nothing but 1.5, right? So the answer C would be the correct option. Okay? But in case they ask for an irrational number between root 2 and root 3, what will you do at that time? Very simple. Just take root 2 plus root 3 and divide it by 2. By using the average method, you can actually get an irrational number between two irrational numbers. Right? Okay. Moving further to the next question. Question number 9. The value of 1.999 in the form of P by Q. There is a typical method of doing these type of questions which we will refer from NCERT. So let's proceed with that. Solution. Let's x is equal to 1.999, that is being repeated. Because there is only one digit in repetition, so we will multiply both the sides by 10. If there are two digits in repetition, we will multiply by 100. And three digits are repetition, we will multiply by 1000. And so on, we go with the multiples of 10. Okay? Let x is equal to this, and this is your first equation. By multiplying 10 both sides. Now you know why I am taking 10 both sides, because there is only one digit in repetition. Okay? So we will get 10x is equal to 19.999 in repetition, and this will be our second equation. Once you get two equations after multiplying, now subtract equation 1 from equation 2. Right? How do we do it? Simple. 10x means left hand side of second equation minus left hand side of first equation. Then 19.999 in repetition minus 1.999 in repetition. You can use the vertical method also to subtract if you find it a little bit confusing. Otherwise, you can simply make it 9x is equal to 19 minus 1 would be 18, and 999 will be subtracted from both the ends. So it will be x is equal to 18 by 9. When you divide it, you will be getting 2. So the value of 1.99 is nothing but 2. Right? If the value of x is 2, we have assumed that x is equal to 1.99. So the value of 1.99 would be 2. Option C is the correct answer. Moving to question number 10. The question says, what is the value of 2 root 3 plus root 3? 2 root 3 plus root 3. See, sometimes it's very easier, but sometimes we get confused when this particular expression is there in the larger questions, right? So people end up choosing this option because they add the irrational numbers, but that's not possible. Actually, irrational numbers can be referred as some constants. At times we say like 2x plus x is what? 3x. 2 apple plus 1 apple is what? 3 apple. Similarly, 2 root 3 plus 1 root 3, right? It is 1 root 3 is what? Nothing but 3 root 3. So option C will be the correct answer. Next, question number 11. It is root 10 product root 15. Now whenever you have to multiply the roots of composite numbers, these are the roots of composite numbers, right? 10 and 15. We will break down the numbers into the product of prime numbers, okay, like this. Now you can see that 2 by 5 by 5 by 3 is given. 5 is in a pair, so 5 will come out and root 2 by root 3 will remain, that is 5 root 6. Can you see the option? Yes, option B is the correct answer. Understood? Yes. Moving to the next, question number 12. The number obtained on rationalizing the denominator of 1 by root 7 minus 2. So let's see how do we rationalize actually. Let's write our number, that is 1 by root 7 minus 2. Now to rationalize any number, you need to take the number which is in the denominator and multiply the numerator and denominator with the conjugate of this number. Now how do you find the conjugate? Very simple. Just change the sign in between the two numbers. So we will be multiplying by root 7 by plus 2 upon root 7 by plus 2. Okay. Now it is 1 times root 7 plus 2. See, I have not taken whole root. It's only on 7. So be careful into this. Then root 7 minus 2 and another bracket of root 7 plus 2. If you are aware with the identity a plus b multiplied by a minus b is a square minus b square, the denominator is very easier for you to solve. See, a can be referred as root 7 and b can be referred as 2 and the sign is minus and plus. So we will use the identity and we'll take the square of first number minus the square of second number. Okay? Now, it is root 7 plus 2 in the numerator divided by root 7 square is 7 minus 2 is 4. So this is root 7 plus 2 divided by 3. Can you see the option? Yes, it is that. The option A of question number 12 will be the correct answer. Moving to the next, question number 13. 1 by root 9 minus root 8 is equal to what? So the very first thing you have to look when you are rationalizing. Okay, how do I know that I have to rationalize? Whenever you have numbers in root in denominator, or you could say whenever you have irrational number in denominators, for sure you are going to rationalize. Okay, so I'll write root 9 minus root 8 here. Then as we can see that the roots are of composite number. So first we will turn these composite number into the product of prime numbers. Okay, so let's do it. 3 by 3 would be 9 and this would be 2 by 2 by 2. If you will simplify, you will get 1 by 3 minus, only one pair will come out, 2 root 2. So this is your original number, right? Again we will use the same concept because we have to rationalize. We will be multiplying by the conjugate. This time it will be 3 plus 2 root 2 divided by 3 plus 2 root 2. When you will multiply, you will get 1 multiplied by 3 plus 2 root 2 bracket divided by 3 minus 2 root 2 and then 3 plus 2 root 2. The numerator would be 3 plus 2 root 2 because we are multiplying it by 1, and in the denominator we will use again the same equation a square minus b square, that is 3 square minus 2 root 2 whole square. So you will be getting 3 plus 2 root 2 divided by 3 square is 9 minus 2 root 2 is 8, that is nothing but 3 plus 2 root 2 divided by 1, that is 3 plus 2 root 2. I hope you can see the option 3 plus 2 root 2, that is option number D. Okay, moving to the next question. Question number 14. After rationalizing the denominator, see, rationalizing the denominator of this expression, we get the denominator as, they are not asking for whole number like the whole expression, they are just asking for the denominator. So let's do it. We'll just simplify we will note down our number 3 root 3 minus 2 root 2. And again, when we know we have to rationalize, we will use the conjugate of the denominator, that is 3 root 3 plus 2 root 2 divided by 3 root 3 plus 2 root 2. Okay? And then 7 multiplied by 3 root 3 plus 2 root 2. I am not going to multiply the numerator because they are not actually demanding for it. So I'll just focus on the denominator in this case. However, you can do it, but it's not necessary. In this case, 3 root 3 square minus 2 root 2 square. Now, how I have converted? I hope you remember from the last week questions, we were using the identity a plus b, a minus b as a square minus b square. So, I have implied that same identity here. Okay. Now, 7 multiplied by 3 root 2 plus 2 root 2 divided by 3 root 3 square. See, if you want to check 3 root 3 into 3 root 3, you will be actually getting 3 3s are 9 and root 3 is 27. So you can utilize that directly here. Minus 2 root 2 square is 8. And that is 7 multiplied by 3 root 3 plus 2 root 2. When you will subtract 27 minus 8, it is 19. Now, as we are not able to cancel anything in numerator and denominator, we will focus only on the denominator, which is the demand of the question. So, the denominator is 19, option number B. Okay? Yeah. Moving to the next question. This is question number 15. The value of root 32 plus root 48 divided by root 8 plus root 12 is equal to what? As I have told you, if you see the roots of composite number, your priority should be break them down in the product of prime numbers. So, note down the expression root 32 plus root 48 divided by root 8 plus root 12, and then root 32 can be expressed as the product of 5 times 2 plus 2 2s are 4, 2s are 8, 2s are 16, 3s are 48 divided by 3 times 2 plus 2 times 2 by 3. Right? This is the easiest form. If you can do it directly, that's well and good. Okay? So this is 4 by root 2 and this is 4 by root 3. The denominator is 2 by root 2 plus 2 by root 3. As we cannot cancel anything currently, we will simply take commons. Can you see 4 common in the numerator plus root 3 and then 2 common in the denominator, that is root 2 plus root 3. Now both the brackets are similar. We can cancel it out and you left with 4 by 2. When you cancel it, you actually get 2 as your correct answer. The option number B will be the right solution. So we just have to do one thing, break down these numbers into the product of the primes and the roots and then take common in the numerator denominator. You'll find the same brackets, cancel them out and your answer is there. Moving to next question, that is question number 16. Question number 16 states, if root 2 is equal to 1.4142, then root 2 minus 1 by root 2 plus 1 to the whole root is what? Now, there are so many roots, right? It gets confusing if you directly put the value of root 2 here. So, never do that. Until unless you reach to a proper solution, do not replace the value of the irrational numbers which are given. Okay? So, what are we going to do? We will hold this root, the bigger root, and we will rationalize the number which is inside. What we will use to multiply? Yes. We will use root 2 minus 1 to multiply. Why? Because this is the conjugate of the denominator. Because there is plus sign, so we will be taking minus sign. Okay? Now, if you see upside in the numerator, you will be getting root 2 minus 1. And then in the denominator, it is root 2 plus 1, root 2 minus 1. Don't cancel anything here. We have a root at the top. Okay? Now, simply take the bigger root, and in numerator you can make it as root 2 minus 1 to the whole square, because there are two similar brackets. And at the bottom you can imply the identity, that is a square minus b square. So root 2 square minus 1 square. Right? Now, again we will not disturb the numerator. It's root 2 minus 1 whole square divided by root 2 square is 2 minus 1. So at the bottom, what do you get? You actually get 1. And at the top it is root 2 minus 1 whole square. Now, if you see, you can simply cancel out this square root by this square, and you are ending up with this. Why have I taken half power? Because root means power 1 by 2. Okay? You can cancel it out and you are left with root 2 minus 1. Now this is the right time to actually put the value of root 2. You can simply put 1.4142 minus 1. When you will subtract, you will get 0.4142. And that is your option number C. So option C of question 16 will be the correct answer. You can easily see that it was easier to substitute the value of root 2 when I have solved the whole rational value. Right? When I rationalized it first, and then whatever is the answer, I have replaced the value there. So use the same approach. Now, question number 17. Okay, so question number 17 is 1/4 root of 1/3 root of 2 square. Okay, seems a little confusing, right? There are so many roots and so many numbers. Simple. Hold your 2 square. See, always hold this value which is inside. Hold this value first, 2 square, okay? And then third root, this is root and then 3 is written, so this is 1 by 3. And then this is the fourth root, right? So this is 1 by 4. And you know, when the numbers are written in such a way that a to the power n to the whole power n to the whole power q, something like this. So we can simply write a to the power n to the power n to the power q. You can multiply all the powers. Okay? So simply just multiply these parts. 2 by 1 by 3 by 1 by 4. When you will cancel it out, you will actually get 2 to the power 1 by 6. Can you see this option? Yes, it is there. So option C will be the correct answer for question number 17. Moving further, question number 18. It is again the similar one. What we have to do? Third root of 2 multiplied by fourth root of 2, right? And then 12th root of 32. Do you remember that I told you never ever go with the roots of composite numbers? So my first priority should be to actually convert this 32 in the power of prime numbers. So if you know, this is the power of 2 to the power 5, right? It's the power of 2. When you multiply 2 for 5 times, you get 32. Now I'll be converting these numbers into their proper parts. So 2 to the power 1 by 3, because it's a root. And then this is 2 to the power 1 by 4. And this one is 2 to the power 5 by 12. Because the bases are same and they are in multiplication, we will be adding all these parts. Okay, so 2 to the power 1 by 3 plus 1 by 4 plus 5 by 12. Now I hope you remember how to add the rational numbers, or simply just go with this process. 2 to the power, take 12 as LCM, because 3, 4 and 12 has LCM, that is 12. And then 4 plus 3 plus 5. You will be getting 4 plus 3, 7 plus 5, that is 12. 12 gets cancelled, 2 to the power 1, and your answer is nothing but 2. So yeah, option B will be the correct answer. Okay? Yes. Moving to question number 20. The value of 256 to the power 0.16 multiplied by 256 to the power 0.09. Quite complicated parts, right? Simple. Just write here 256 and its power 0.16 multiplied by 256 to the power 0.09. We know when the bases are same and they are in product, right? They are in multiplication. We can simply add their powers. Add their powers. 0.16 plus 0.09. I hope you know how to do it. 0.16 and 0.09 is nothing but 0.25. Okay? So this is the rough work. It is 256 to the power 0.25. Again, this is a complicated value. Instead, we will actually turn this power 256 0.25 into rational number. You will find 25 by 100, so that is 1 by 4. 256 to the power 1 by 4. Do you know that 256 is nothing but the square of 16? Great, if you know it. So 16 by 16 to the power 1 by 4. Again, I need power 4, right? So I can simply make it as 4 by 4, 4 by 4, 4 by 4. Every 16 can be written as the product of 4 by 4. Okay? So it is 4 to the power 4 multiplied by 1 by 4. Power. Then 4 multiply 1 by 4, multiply it and you'll be getting 4 to the power 1. That is actually 4. So yeah, option A will be the correct answer of question 20. Moving to the last question of this exercise, that is, which of the following is equal to x? Now you need to solve all these questions and need to tell that which actually comes as a result x. Let's start with option B. Okay, bases are same, so the powers gets added, right, in the product. Great. X to the power 12 by 7 plus 7 by 12. The LCM of 7 and 12 will be 84. 12 by 12 is 144 plus 49. This seems too complicated, but let's do it. 3, 9 and 2, 84. Oh my god, this is quite complicated. It's not equal to x. Okay, let's come to the next option. Option C. This is root of x to the power 3 and then whole power 2 by 3. Simple. X to the power 3, then power 1 by 2 and then whole power is 2 by 3. Why I have written 1 by 2? Because there was a root. Okay. Now it's x to the power 3 by 1 by 2 by 2 by 3. All the powers get multiplied because there is a power over power. Okay. So 3 cancel, 2 cancel. So this is x to the power 1, which is nothing but x. Okay, this can be the correct answer. Moving to the next, B part. Then it is x to the power 4 whole power 1 by 3, and this is the 12th root, so we will be taking 1 by 12. When you multiply, it is x to the power 4 into 1 by 3 into 1 by 12. Power over power gets multiplied. 4 by 3, this is, okay, 1 by 3 into 1 by 3, so you will be getting x to the power 1 by 9. Again, that's not equal to x. Moving to the next, this is x to the power 12 by 7 minus x to the power 5 by 7. Okay. Generally, if the bases are same, we actually add the powers, but only when they are in the form of product. There has to be a multiplication sign. But here the sign is of negation, so we cannot solve it further. We cannot solve it further until we have some values. So there is only one option which has x as the correct answer. So option C of question number 21 will be the right answer. I hope you understood all the steps that we have done from question 1 to 21. Later, we'll be moving to the next exercise. Take care.